Okay, this quick check is talking about the electrolysis that we're doing in the class. So the first thing, just some statements to get things sorted out. In an electrolytic cell, the negative electrode, okay, and the reason it's negative is because it's connected to the negative end of a battery, because the battery is causing the chemical change. Well, the negative electrode is negative because it has too many electrons. Too many electrons. And that's because it's connected to the battery, and the battery is like a little pump, okay, and what that does is to cause electrons to be pulled in one side and pumped out the other. So this side is negative because it's going to have electrons pumped into it. This side will be positive. Okay, the chemicals that come into contact with the negative electrode, well, if we have an electrode with too many electrons, then they're going to gain electrons, and gaining electrons is reduction. So Leo the Lion says GER. So gaining electrons is reduction. And if that's reduction, then this guy must be the cathode. So because of the battery, one of our electrodes has too many electrons, and so whoever touches it is going to gain electrons and be reduced, so that's the cathode. Okay, in the same way, in an electrochemical cell, the positive electrode is because it has too few electrons, and that's because it's connected to this side of the battery, and the electrons have been pumped out of it. So chemicals that come in there, they're going to lose electrons. They're going to touch the electrode, and the electrons are going to be pulled away. So that is oxidation. Losing electrons is oxidation. And if it's oxidation, then that's called the anode. And that's all because it's connected to that end of the battery. Okay, next one here. Now here's this chart. This chart is very useful. And what we've done is that the standard way to look at this is to have the reduction potentials. Okay, right, everything has a reduction. But what we've done is go back and change these. Okay, we turned them around, we changed the signs, and then we put them from high to low. And so this is now the oxidation potential. So there's a reduction potential chart, and just by flipping everything, we have the oxidation potential chart. And that's important. We're going to need to use those to compare things. So in an electrolysis experiment with copper bromide, the negative electrode will be in contact with water, and who's going to be attracted to the negative side? Okay, let me switch colors here. Okay, who's going to be attracted to the negative side? Okay, the negative side is going to be attract the positive ions, so the Cu2+. So you're not going to get any bromides over there because they would be repelled. So those positive ions will migrate over to the negative electrode, and the water is going to be there. Okay, the reactions that might occur, okay, if you have a negative electrode, they're going to gain, so it's going to be reduction. That's why you want to look at this chart. That's the important chart. What are the two possible things? Well, the copper could pick up electrons. So copper 2+, we're just going to say, could pick up a couple of electrons and become neutral copper. Or the water, and here we have to look on here, the water, there it is. The two waters could pick up 2 electrons, and it would become hydrogen gas and 2 hydroxide ions. Okay, now, which of those is really going to happen? We got to look at their numbers. So this is negative 0.828, and the copper is positive 0.337. So who's going to happen? The copper is going to happen. So whichever one has the larger reduction potential at the negative side, the larger reduction potential, that's the one that's going to happen. Now with the positive side, you can see that different things going to happen. Who's going to go to the positive side is the negative bromide. Now water will be there anyway, but the negative bromide will be there. And so these are going to be oxidations. And the reason is because if we have a positive electrode, okay, that means the electrons have been pumped out of it, so anything that touches it, its electrons are going to be taken away as well. Okay, and losing electrons is oxidation. So I always think of this sort of like a little, vacuum cleaner. So if you touch it, your electrons get drawn away. So what can happen here? Well, we have the bromide. So here's an equation. And the water, okay, the water can lose electrons, and so this time we need this equation, okay, where the water can lose the thing. So we're going to copy those two down. So bromide can turn into bromine by giving off 2 electrons, and it has an oxidation potential of -1.07. And the water, it's possible for that to lose electrons. So 2 waters could turn into O2 plus 4 H pluses plus 4 electrons. So again, we have to see that here's water with electrons on the right, here's bromide with electrons on the right. Okay, these are losing electrons, so this is all oxidation. Okay, losing electrons is oxidation. This one has a number of -1.23 volts. So of these two, which one's really going to occur? Whichever one with the larger oxidation potential, which in this case is a smaller negative number. The less negative is the larger number, so bromide will change. Write the two possible, circle the ones. Okay, so write the overall reaction. So we had put these two together. So we could say on the left side, okay, here's 2 electrons, here's 2 electrons. They're going to cancel. So the copper 2 plus 2 bromides, and that's coming from the solution of copper bromide, will turn into copper metal at one side and bromine, which is a liquid, at the other side. So that's going to be the overall reaction that occurs, and that is the quick check. So notice what's going on is for electrolysis, then we have to figure out water can change or the ion that you have dissolved in can change. So we have to figure out who's going to go to the negative side, the positive ion. Okay, look in the chart and find out the two possibilities, water and the ion, and whichever one has the larger number, that's the one that occurs. For the positive side, we have to look at oxidations, and again, either the negative ion or the water. Okay, and in this case, the negative ion had the larger number, okay, less negative, and so that's the one that occurs. And then we just put them together for the overall. That's the quick check.